So good evening, everybody. It's nice to see some known names, and welcome to our very first webinar. So also at the end of the webinar, tell us what you thought and what you would improve. And yeah, we are from almost everywhere around the world. People who have enlisted for the webinar come from very different parts of the world, and this is really nice for us at IDUN because it's nice to have a technology that is so international. So we're gonna make a webinar on our first product, which you can already buy on OpenBCI and in our stores. That's the DRYODE Alpha. And we are going to present two use cases where we've been using those dryodes. And this is also a place for you to ask questions. We have 6 people from IDUN in the attendee and panelist list. So my co-founder, Simon, Andy, which is specializing or knows everything about amplifier, electronics, how to fixate the electrodes on the body. Mark, which is specializing on the application. And we have Kai, which is our neuropsychologist, and Moritz, our head of engineering. So feel free to ask technical question or whatever question you have. So I will request remote control. And yeah, also as information, we're going to record the session. We would like to post it online afterwards so that people who could not attend still have a chance to see what we were talking about. So just that you know that. And also, if you have any questions, you can write it in the Q&A chat or during the official Q&A after the session, you can raise your hand. If you click on panelist, you can raise your hand and Simon will give you the voice. So let's start. Oh. And I need your help. So, round of introduction from presenter coming next. We're going to talk about our first use case, augmented gaming, with our youngest employee, Mayank Jain, out of Canada. We'll have a Q&A about augmented gaming, and then Andy will be presenting our second use case, sleep EEG Q&A, and then you can ask all your small round of introduction from the presenters. So Severin, that's me. Some of you know me already. I'm the co-founder and chief commercial officer. So if you have any interest in the technology, I'll probably be your first entry point, the first face where you see at IDUN. And we have Mayank Jain. I don't know if he's already there. Yeah, so Mayank, yep, you can, sorry, I'm not seeing you. So you can introduce yourself shortly.
Yeah, hi, I'm Mayank. I'm a first-year undergraduate student at Waterloo for computer science. And at IDUN, I've been working as an application and hardware engineer.
Thank you, Mayank. And Andy?
Yes, thank you, Severin. So good evening from me as well. My name is Andy. I had the privilege to be with IDUN since the very beginning, almost 3 years ago. I'm a systems engineer, and my work in development is mostly on the electronics side, as Severin already said. And I also spend a lot of time basically bringing all the pieces together to form a product.
Thank you. So we're going to hand it to you, Mayank. So I'm just going to stop my remote control. You can take over. And Mayank's going to show us what he's been doing in his lockdown in Canada.
Yeah, so I've been working on using the DRYODE alphas to augment gaming. So this project initially started out with trying to completely control video games using our brain. So one of the first projects I created was this universal controller that can be used to play video games completely using biosignals. So we created this controller to play video games that are like first-person games, where you can move around, and whether that be like a first-person shooter or just an adventure game. So the idea is you could use a combination of EMG and EEG to get a whole bunch of different controls. So this controller had it so that if you activated neurons in your left leg, you could turn left. If you activated neurons in your right leg, you would turn right. If you did both legs at the same time, you would move forward. And then you could use each one of your right and left arms for different actions. And then you could add on to that using EEG. And so the most reliable controls that we found were blinking, jaw clenching, and alpha peaks. So in case you don't know, if you close your eyes, that's a really good way to increase the alpha frequencies in your brainwaves. And that's something we can easily detect and use as a controller. But later, what we realized is that you can play games completely using your brain, but it doesn't always make sense. Because while we could move around the map and do different things, it wasn't as reliable as using a controller or keyboard. And that's something most people would rather use. So instead, we decided that it makes more sense to augment gaming. So you can use a keyboard and mouse to do all the regular controls, like the basic stuff, like walking around, interacting with certain items, things that you need to be working with 100% reliability. But then we can use biosignals like EEG to add on to that and activate certain abilities in the game that aren't necessarily 100% required to win the game or have a great experience. So that's why we moved on to using alpha waves to activate certain abilities in games. So if you look at these different graphs, it may not make sense right away, but what you want to focus on is the blue bar. So that blue bar is the level of alpha activity that we detect in a person's brain. And that's just a certain frequency of brain waves. So when a person's eyes are open, there's very little alpha activity. And when a person's eyes are closed, you can see the blue bar shoots up. And that's something we can easily detect and use as a controller. So the first example we had was with Tomb Raider. So in Tomb Raider, this woman has the ability to activate something called survival instincts. And that basically just turns the whole world black and white and highlights any interesting items yellow. So you can see that here, when I close my eyes for a bit, it activates enough alpha activity that it activates this ability, and then she can see that totem that you otherwise wouldn't see. So now seeing this totem isn't something that's really important in the game. Like, you don't need it to win. So it's okay if it works with 95% accuracy versus something like moving forward and shooting. If it doesn't work with 100% accuracy, it gets really frustrating if you're like fighting a boss or something and it doesn't work, because then you lost because of something that was outside of your control. Versus this ability isn't 100% necessary. And the other interesting thing was that the way you activate this ability physically correlates with the way that this person is using the ability in the game. So if you think about if you had this ability in real life, like the ability to just see things you wouldn't normally see, like intuitively you'd think that, okay, you'd like calm down and sort of focus. And similarly, like the way you're activating that ability in this game is to physically do that same sort of mental state. So you're entering that mental state of like calming down and focusing, and that activates the game in the brain. Sorry, that activates the ability in the game. And now it's way more interactive, and it's a new way of engaging with games beyond just clicking buttons on a controller. So this is the second use case we had. It's also very similar, it's just a different game. It's called Horizon Zero Dawn. Similarly, this woman has an ability with her bow and arrow where it'll slow down time, so the player has a better opportunity to land their hit. Again, this isn't like completely necessary to win the game, but it's just an augmentation. And it's interesting because, again, you're focusing and sort of calming down, and then it slows down time. So it's a nice response to your mental state. So beyond just improving gaming from a player perspective, we realized that we can also use EEG to improve games in the development stage. So playtesting is this concept where video game developers will create a game and then have players test the game beforehand to get feedback on it. So the traditional methods of playtesting are to either directly observe players, have them give real-time feedback, or fill out surveys at the end. But all of these have their drawbacks, mainly being that having people in the room with you creates biases. So like if you imagine taking a test and having your teacher over your shoulder, like that's obviously not going to be the same as just writing a test alone. So having people in the room observing you creates biases. And people's behavior require interpretation, both by someone observing and even if the person was just explaining how they feel. And people don't completely understand how they feel, which is why EEG has that added benefit of being able to get us closer to the ground truth of what people are really feeling. And the problem with surveys is that you're limiting the range of answers that people can give you. And it eliminates certain nuances. So if you just say, how are you feeling on a scale from like 1 to 5, the person's sort of restricted to, like, let's say you're measuring sadness. They can't tell you like little nuances of how they feel. It's like a very quantified thing, which can be good and bad. So when we're using EEG, the advantages are that we can really measure someone's arousal. By that, it means like how powerful is the emotion. That's something we can easily quantify using EEG, and we can measure how engaged people are. And right now, EEG is always going through research, so there's a potential to discover more biomarkers, more metrics of how a person's feeling, and using that to evaluate games. So the problems we need to tackle for this would be the fact that data can be really noisy. Sometimes it's hard to validate because there is no like gold standard, like 100% accurate method of measuring emotion. And it can be uncomfortable during gameplay. But the alpha is already helping with this. So like the silicon that we use is really comfortable. So like I've been using them for a lot of projects and they're just way more comfortable to use for long periods of time versus most other electrodes, or if you have like a clinical EEG. So this is, again, just to show this model of quantifying emotion. It's called a valence arousal model. And arousal is just basically how powerful that emotion is. And valence is whether it's a positive or a negative feeling. So intuitively it makes sense. Like for example, if it's a really positive emotion with that's high valence, and if it's a very powerful emotion, that's high arousal. And that would be like if you're excited. And then on the opposite spectrum would be like low valence and low arousal would be like you're sad or tired. Yeah, and that's it.
Thank you very much, Mayank. That was cool to see all at once. So yeah, people, if you have any question for Mayank or generally, or ideas that you want to share with us, just either write in the chat or, yeah, Evgeny has a question. So I think maybe Simon, you can unmute him.
Yeah, Evgeny, I think you should be able to speak now.
Oh, yes, it's much better, but my English is not so good as yours.
Not a problem.
But can you hear me? Yes.
Yeah.
Mm-hmm.
I'm from Russia originally. Really, my friend should be here instead of me because he understands much better than I do. But I'll try to ask these questions which he asked me to ask. So the first one is, I wrote, what do you think about sleeping with these electrodes? For example, if we need to take EEG signals during the whole night, during sleeping, what could it be?
So maybe we'll have just afterwards Andrea presenting sleep EEG. So the alpha are really good for any areas which are frontal and behind the ear. Because it's the flat design. So we have different designs in the pipeline to go full scalp EEG, but currently the alpha is a flat one. So it's going to be good for frontal EEG for sleep. The thing that you have to make sure is the snap joint, so where we attach the cable, that it's in a location that it's not going to press too much. That's like more of a design thinking. problem, but you can do sleep EEG with those electrodes.
For example, you still hear me, yes?
Yes.
For example, if you take some hat or cap, I don't know, and put inside several electrodes, and we'll try to sleep with them, it will be okay. You think about from the point of view of taking information and from the point of view of comfortable sleeping.
Andy, maybe do you want to give your inputs?
I'm sorry, I'm not sure if I understood correctly, but are you asking if it's
Yes, I
possible?
can repeat in other words if you want. Yes, one more time. So, for example, we take some material, some hat or some cap, and put inside it some electrodes, for example, and then try to sleep with them the whole night, taking the whole information from all these electrodes. So the question is how comfortable it will be sleeping with them, and the second how the signal will be, they will be very with the quality of signal.
Okay. So about the signal quality, I'm going to talk in a bit, and about the comfort. So from the side of the electrodes, it is barely even noticeable. The problem there is the whole device you integrate the electrodes into. I mean, if you just use cables or something, then these are gonna obstruct, if you move in your sleep. So a device should really be in a soft enclosure or something like that.
So you will not feel the pain or something like this, for example.
Yes, exactly. But the electrodes themselves, our electrodes are completely soft. So the electrodes are certainly not gonna hurt you in any way. You can barely even notice you have them on.
Okay,
For example, I've used those electrodes for like 6 to 8 hour sessions in a row, which is like, I guess, approximately how long a person would be sleeping, and they're perfectly fine in terms of the comfort level. And it was just, I had 3 electrodes here, 3 alphas on my forehead, and just a sports headband over it.
And the second question, if you are ready, is if to speak about the all kind of signals which, for example, we need. I'm trying to open. So we need to take the EEG signals, EMG signals, and EOG signals, if you know what is it.
Yeah.
Everything is possible, yes?
Yes, everything is possible, again, from the electrode side. The fixation is the critical thing there. For EOG, you want to place the electrode below your eye, and you need to figure out a way how to attach the electrode there, because in contrast to gel electrodes, these are not self-adhesive.
We have a quick question to Mayank. How reliable is the detection of blinks for game commands?
Yeah, the blinking is pretty reliable, but I mean, that's the case for pretty much any EEG. The spikes are really, really obvious. Like even the main trouble is usually with alpha detection. Like that one's more, well, not challenged, but it's more troubling than eye blink. And even that you get pretty reliably. So like, for example, the Tomb Raider video, the full raw footage, I got it working like 6 or 7 times in a row.
In the Q&A, do we have Kai in the meeting? So we have like curious to know more about the balanced arousal model. How do you get from EEG signal to emotional states? That's a very good question, Alexander. If Kai is our new psychologist is here.
I unmuted him, so he should be able to speak.
So,
well, I am here. I don't know whether you can hear me.
Yes.
Great. Do you want me to comment now, or do we do that to the
Q&A
session?
Yeah, you can comment now.
Yes. the way there is a way from the EEG signals to the to the emotional classification, but that depends very much on how many channels we have. There are many possibilities at the moment described in the literature, and if there are sufficient channels, there are models that work with classification, with machine learning models classification. Training the model and then getting classifiers, and those pretty much work with those two-dimensional valence arousal model. And yeah, I think we can go into details later, but I think this is the one way. If you have sufficient channels, you have many possibilities to get from the raw signal to classified emotions.
Yeah, thank you. I think this is like a topic for itself. We could do a webinar just on this. And so how much do the movement during sleep affect the signal quality? So yeah, movement artifacts are mainly the biggest problem. So Andy, maybe you want to jump into how we try to solve this problem?
Yes, so I'm going to show later. So we are basically with the dry electrodes at the same level of artifacts as with gel electrodes, but the origin of these artifacts is somewhat different. So one major factor is that with dry electrodes we don't have any control over the electrode skin interface compared to pre-gelled electrodes. So basically the sweat is going to form the interface, and well, we cannot control that, right? But usually it's not a problem. It works very well.
Thank you. So how much do you focus on EEG processing versus hardware development? That's a good question also. So we, from a company history, we focus a lot on hardware first, with the first focus on this interface between the skin and the sensor. So that's like the core of the company. And currently we are expanding our whole team in focusing in EEG processing and also in machine learning for emotion detection from in-ear EEG. So this is where we are going as a company. But like, definitely if you have good data, you're gonna have good models. So this is why we also focused a lot on the hardware. Maybe Mayank, do you have to leave for NeuroTechX like soon, or otherwise we can just jump in for the other? You're muted.
I have another like 5 minutes.
Okay, cool. So it's, someone said it's really nice to see research that also includes in-game mechanics in relation to the EEG data. Alpha Power solution for Tomb Raider game was a good idea. However, how do you think that would affect the gaming performance where it's much more action-based? Because closing the eyes would definitely impact the gaming performance. Have you ever considered what could be the alternative to this?
Yeah, so there are also, like I've worked in the past with algorithms that measure your focus. They're not as reliable, which is why I focus on alpha. So yeah, I understand what you mean, but also like the ability it shows in Tomb Raider isn't one you would use during combat. So it's just like it highlights interesting things in the environment, but that's not really important if you're like in a combat situation because like you can see where people are. But an alternative, like if you needed something that's like during a high action situation, it would probably be something like how focused you are. And then we can measure that using different bandwidths, like the gamma band has a really good association with focus.
Thank you. So Maria, maybe do you want to say something? Simon's going to unmute you.
should be able to speak now, Maria.
Hi, yeah, thank you everyone, by the way. I was asking, I'm a digital designer and I would like to know if you have and which type of scenario have you considered, like not just in gaming, but in other like retail spaces or events that have you considered or how to use it? I'm kind of learning about neurotech, so I'm interested in that.
Yeah, so one other project we're working on is actually this IoT demo room that's also more focused on design, where we're using EEG to control different animations and lights in a room. So one use case we created was where we have this cherry blossom that it reacts in real time to your alpha levels.
Okay, and always wearing it, right? It's
Yeah,
also just standing in one space, or you can walk around and feel the experience. I'm just thinking about how to apply it on different spaces.
So that would depend on the hardware you're using. So if you designed EEG hardware that is meant to be portable, then you can totally walk around. Like for example, if you use something like a Muse headband, that's designed to be portable, and you could just walk around the room with that. But like one thing to keep in mind is that the more you're walking around, that creates something called motion artifacts in EEG, which lowers the quality of the data a lot. So depending on, you just have to design an interface with those things in mind that's portable and reduces these motion artifacts. So basically just keeping the electrodes really tight on the scalp so they don't shift around.
Right, and so you have like a limited square meters to walk around.
Oh no, like if you can walk around with it, you can just walk around wherever because it uses Bluetooth. So as long as it's within the range of a Bluetooth connection, it would be fine.
All right, okay, perfect. Thank you.
So we have like Mayank, there is one, I thought there was, oh yeah, there was one more game question and then the rest will be for Andy. So do you think about creating a game based on your solution and game that would be dedicated to people with depression, in which biosignals would decide about the scenarios awaiting the hero character of this game? Or have you thought about a mobile application that, based on biosignals, would serve as a detector of impending depression or other anomalies?
Yeah, that's interesting. I haven't thought about that too much, to be honest. But once you get into mental health, there are a lot more implications. Because like even in regular mental health diagnoses, there's like a lot of people who have been misdiagnosed with depression for years. So if you did use something like that, you want to make sure you're not creating a negative feedback loop where you're telling someone they're depressed when they're not, and that might actually increase their chances of depression.
And also, like from our customer that are using our electrodes, we're quite a few which are doing treatments like game treatments for HDHS and so in neurofeedback. So there are a lot of applications possible in neurofeedback.
Yeah, you just have to be more careful with them.
Yeah.
They have to be proven to work.
Okay. So for you, Andy, there are a bit of questions about the acquisition. So from Andre, he missed about how we are amplifying the signal. Is there an acquisition box that the electrodes leads are going into? And is he building this himself or is it third party? Thank you.
So the DRYODE Alpha uses a standard snap joint interface. So basically you can use it with any kind of amplifier you want. That can either be connected with cables or it could be a device which uses these connectors.
Okay, thank you. So I think we're gonna go for the second presentation. We're half time short. I'm not forgetting all the open questions, but I think they will also be, we can do it after Andy's presentation. And Mayank is going to leave us because he's presenting a NeuroTechX. For all the other people who don't know NeuroTechX, that's also something you should check out if you're interested in neurotechnology.
Bye.
Bye, Mayank. Thanks.
So Andy, the floor is yours.
Just trying to. Trying to get the presentation going. Simon, can you make it full screen? Perfect. Yes, so as the second use case, I'd like to talk about something maybe a bit less action-loaded as gaming, but at least equally important. I'm going to talk about sleep. Now, as of course everyone is aware, a good night's sleep is very important, and bad sleep can have very adverse effects on our lives. And at the same time, some health conditions can also change the pattern of sleep stages and can manifest themselves in abnormal cycles of these stages. And some of these diseases are coronary heart disease, diabetes, or sleep apnea. So sleep monitoring is important to tackle these kinds of problems. And when we're talking about sleep monitoring, we're basically talking about identifying the different sleep stages. Now, these cycles of sleep stages, or the temporal organization into different stages during sleep, is what defines the macrostructure of sleep. So on the right, you can see a hypnogram, which is basically showing at what stage of sleep a person is over a couple of hours during sleep. And commonly, these stages are defined as the rapid eye movement stage, or the REM sleep, and the non-rapid eye movement stage, which can be further subdivided into 3 or sometimes even 4 stages. And an increasing number there denotes deeper sleep. So the non-REM 1 would be very light sleep, and non-REM 4 would be extremely deep sleep. And to some extent, these stages can be recognized by smart devices like smartwatches on the bottom left there. But these devices usually only have very limited data to work with. Usually that is an accelerometer and an optical heart rate sensor. And the accuracy of these assessments is not ideal. So this brings us to the microstructure of sleep. This is basically specific neurophysiological events which make up the differences between these stages. And this information we can only get by means of an EEG recording. And the presence or absence of these microstructural events can give a much more detailed and accurate account of the state of sleep or the quality of sleep. And on the right side, you can see 2 examples of such events. Marked in blue would be a slow wave event, and marked in red is what we call a spindle. So in order to fully understand sleep, it is essential to have a very detailed account of the brain activity. The problem is, as we already briefly discussed, EEG recordings are very obtrusive. Typically, they take place in a sleep laboratory. As you can see in the picture there, they require cables, and they take place in an unfamiliar environment. And this alone can severely impact the sleep quality. Only even because you're sleeping in a different place, you're not at home. So this has been termed the first night effect. So going to a sleep laboratory for one night is not ideal. It does not really lead to a very good representational data set of your sleep. So what we'd actually need is a way to record an EEG in free living conditions, ideally at home in your bed. And because there is a natural variability between nights, ideally we would do this over the course of several nights. So this is where our dry electrodes come into play. So only with dry electrodes, we think it actually becomes feasible to do that. It becomes feasible to build a sleep monitoring device, which is as easy to use as a smartwatch. And the key thing here, we think, is reusability. In a clinical setting, the gold standard currently of electrodes are gelled electrodes. Like these blue electrodes you can see in the picture in the bottom right. While these give a very good signal quality, they are single use only. They need to be replaced after every use, so after every night in our case. And dry electrodes, on the other hand, can be integrated into a device and just stay there. And they can be cleaned, and they work just as well for a second and a third and a fourth time. Now, the important thing, the important question, of course, is can dry electrodes deliver the same amount of information? Can they deliver the same data quality as the gel electrodes? And luckily for us, ETH Zurich's Mobile Health Systems Lab has provided us with an answer to that question in form of a publication. In their study, they have assessed and compared the quality of EEG recordings with traditional gel electrodes and with our DRYODE alphas. And because it's usually not that straightforward to assess electrode quality, they had to define an extensive protocol, and they have developed a way to reduce the variability and basically give us an account of how well these electrodes work in comparison with gel electrodes. So they base their comparison on the macrostructural scoring. So basically how well or how similar the sleep stages are scored with the two different electrodes. Then they have assessed the macrostructural characteristics, how well these match. And they also compared the signal to noise ratio, where the signal being these macrostructural characteristics. And what they found is basically that signal to noise ratio is very similar. There is a very high agreement in the macrostructural scoring. So basically the information we get out of the EEG is the same with both types of electrodes. And maybe the most interesting, the overall comparable, the overall number of artifacts is comparable. So, or to be more precise, the amount of epochs, or the amount of time segments during the recording which had to be discarded due to insufficient data quality was about equal for both types of electrodes. There is one difference they found, however, which is the type of artifacts is not the same. So there was a significant difference in the amount of slow sinusoidal artifacts, which are marked in red there, which are basically slow oscillations. And these were more prevalent with dry electrodes. And as we briefly discussed earlier, this is very probably due to sweat, as we cannot control the sweat. The amount of sweat that builds up in an electrode or under the electrode. But then again, the overall number of artifacts was about the same. It's just the type of artifacts that was similar. That was different, of course. So what could we learn from that study? Basically, we think it is safe to say that the signal quality of dry electrodes is sufficient to do sleep EEG, to characterize and study the macro and microstructure of sleep. And we also saw again that the fixation is absolutely key. So usually people get used to EEG using our electrodes, try to recreate the way in how they attach our electrodes. They try to do it the same way they're used to with gelled electrodes, and try to tape them directly to the skin. But we think it is better to actually integrate them into something like a headband or some sort of device, which just has not been possible with gel electrodes, but which actually works better for dry electrodes. And to make that even easier, our newest prototype, which you can see on the bottom there, makes it very easy. You can basically just take this electrode and stick it into any sort of device, a headband or a helmet or whatever you want to use. Yes, that concludes my part. I guess we can open the questions.
Thank you, Andy. So we have a few questions. So from Greg, are our electrodes active electrodes, and how well does the macropillar electrode perform as compared with the DRYODE? So for everybody, so the DRYODE alpha is the flat one, and we are having the pipeline, an electrode that goes through the hair. We call it the Helios macropillar. And so question to you, Andy.
Yes, so the first question. The electrodes are not per se active electrodes, so they don't have any active circuitry, but due to how they are built up, you could very easily design a PCB which you then place directly on top of the electrode, basically make it into an active electrode. And the second question was about the macropillar electrodes. So the macropillar electrodes are designed to go through hair, and well, they can perform equally, but it's a little more tricky the fixation is even more important. Well, basically, you have to make sure that these pillars correctly find their way through the hair. But well, if if that is correct, if the placement and everything is correct, they can perform equally well.
So if you're interested in the electrode that goes through the hair or the foams, please get in touch with me. We can get you a quote. So Andre asked, so he didn't quite understand how the dry electrodes kit sticks to the skin. Is this just mechanical pressure added by a cap, or are there any adhesive properties for the electrodes themselves?
Yes, I should probably talk about that a little more. So maybe we can go back some slides. Here, so these are the electrodes, the bottom picture on the right. So basically, yes, it is how you say. It's just mechanical pressure, for which you use a headband or whatever. But around the electrode, there is a not adhesive layer. It's not adhesive, but it reduces the motion on the over the skin surface. So it sticks a little bit in the direction of the skin.
Thank you, Andy. So we have one very specific question from Michael. So does the existence of slow sinusoidal artifacts in the dryodes affect the ability to identify slow oscillations in the EEG signals? Do we know that already, Andy or Kai? Ah, perfect.
I think the data that result from the paper show that the identification of those microstructures in the sleep pattern, they are very well identified. So slow sinusoidal artifacts do not really hamper the ability to identify those slow oscillations. Yeah, that's what the investigations have shown.
Thank you, Kai. Alexander, he would like to know more about the placement of reference and ground electrodes. He's used to be working with the Open BCI Gold electrodes and place them on the earlobes. The DRYODE seems too big for that. What placement do you recommend for the DRYODE reference and ground electrodes? Good question.
Yeah, that is a very good question. So I would still recommend using the mastoid or behind the ear placement. If the electrode is too big to fit there, it's actually possible to cut it a little bit to shape. But that is the best placement.
And the foam might come in handy for those locations.
Yes, the electrode which we saw on the last slide, which is currently in prototyping, will have a smaller contact area, and the connector is further apart, so that should make it easier to place it behind the ear.
So we have also a question from Evgeny. So sorry for asking the question too early before, no problem. So if we know the Muse S device, I think Simon has used that already a few times, and we have one of our engineers who used to be working on the Muse S, and they have this problem with losing the signal during sleep. So if I remember well from our engineer, they have like two problems. One is the battery life, and the second one might be the fixation.
Yeah, I can maybe jump in here as a very vivid user of a Dream headband, which is comparable to the Muse S. And I think the second bullet point in the learnings list of Andy here is very relevant. The fixation is key. What we see as a limitation of some sleep EEG devices is that they're simply, because they have to use this one fits all, that sometimes they don't have enough contact pressure, or people with smaller heads, for example, they're losing contact to the electrodes. So this is a big topic. In the paper, they used excessive taping. And this is also partly the reason why they saw this sinusoidal artifacts, because some of the subjects started sweating during the night because they had a lot of tape on the skin, and this led to artifacts. This is obviously not happening in commercially available devices such as Muse S or Dream, but there they have the problem of the contact pressure and the fit.
Thank you, Simon. Michael has a question on the benefits, or one of the benefits of the DRYODE seems to be reusability. Can you comment on how many times DRYODEs can be reused? How many nights of sleep?
Well, we have not yet seen one fail. So as long as we clean them nicely and remove the dead skin cells which can accumulate, you can use them for many nights. I don't have a number.
Yeah, maybe like from a just quality perspective, the failing spot of our DRYODE Alpha was mainly the mechanical snap joint silicone interface. So this we can make it up to 100 times, that's for sure. But if you don't need to change it, then it can be reused for more. And for the cleaning, we usually clean it with ethanol wipe, and that works also quite good for a long period of time. So enough sleep nights. So Andre also has another question for you, Andy. So thanks for nice talks and answers, Andy. How much of a problem, again, are movement artifacts with the DRYODE Alpha? Do you envision taking them to freely moving into the wild applications? What is stopping this? Thanks.
Yes, so we have done that. We, for example, we have done measurements with skiers and biathletes, and it certainly is possible. However, dry electrodes are more susceptible to movement artifacts. So then it gets even more important to get the fixation right. But it is certainly doable as long as the fixation is tight.
Thank you. So last comment from Daniel, and Alex on the top, I'm not forgetting your question. I know that goes back to Kai on the emotional recognition. But from Daniel first, I'm trying to imagine a commercial use for your solution aimed at book readers. Could your solution record EEG signals while reading in such a way that at the end of the month produces a report for the reader saying, for example, Don Quixote was the reading that most involved your cognitive, that's really cool, your cognitive functions. And when reading The Master and Margarita, level alpha waves was most conducive to your well-being. Based on reports from other users, the app could recommend reading material that could trigger a similar signal in the brain. Is it within your reach, or have I allowed myself to be carried away by my imagination? That's awesome.
Really cool idea, Daniel.
Yeah. So we are thinking a lot about the data side and how we can help have an interaction with the digital world, which is more personalized, so based on what you need. We haven't not yet thought about books, but we have thought a lot about music. So it would be like a similar scenario with music, but with books. And I really like this idea with books. So yeah, Daniel, I know you've tried to be in touch with us a few times. Yeah, I will write you an email back. Cool ideas. And Seth gave an input for this. The signal would vary based on whether they are reading print or screen. yeah, visual artifacts will have a big impact on that type of recording. Very true. So Stats, if you want to raise your hand or if you want to say something about this, it's also a nice platform to exchange. If not, that's also okay.
Sorry, I'm jumping around, but Seth, now you should be able to speak.
Can you hear me?
Yes.
Yeah.
Yeah, so I've run EEG studies before of people reading and also experiencing the same media like via PDF. And there are huge variances between those two different media. So, you know, if even between actually a Kindle e-device versus a full color screen. So, you know, EEG, those visual artifacts are going to play a huge part in that detection. So it's something to consider, and also sort of begs the question of, you know, what kind of signals could we get from experiencing all types of media? How does, as Simone mentioned, you know, listening to music versus reading a book, that could be interesting as well.
Yeah, and the thing is, like digital media, we could theoretically control the input. If you're reading print, it's very hard to know what's being inputted. But definitely a good, I mean, visual inputs, definitely a good, yeah, a good point of yours. That's going to be very different, yeah.
Maybe I can add one thought on that reading aspect. Of course, Seth will have a lot of experience with that, much more than we do, but the eye movements, how they can be calculated out in order not to influence our markers that we actually want to interpret with respect to music. This will be a thing to think about, where, I mean, we don't have the solution to this yet, but this will be more in the domain of data processing, I think.
Exactly. There's a lot of pre-processing to eliminate those artifacts and then to sort of arrive from there. Yeah.
Mm-hmm.
So we have a few questions left. So is contact pressure from Ugo? I guess it's from Turkey, and I'm sorry if I said your name wrong. But so as contact pressure is an important phenomenon for dry electrodes, how do the dry electrodes perform against wet electrodes comfortability-wise? Yeah. We maybe I'll jump in a little bit on this one. So our whole material development and whole material innovation is based on having flexible conformal materials that are conductive, so that specifically when you apply pressure on it, it's not hurting. But that's definitely a very crucial point for having good signals, and that comes back to the fixation and how you design your hardware around the electrodes. I hope that answers all your questions. Yeah, do you have any plans to apply for research grants? If so, what partners will you be looking for to form a consortium? We're always applying for, we're usually applying for research grants. So the last one that we have applied for is more based on the hardware, but going forward in 2021, we will definitely go more on the application side. So work packages for us on the data side are data architecture, machine learning models, APIs, and application, like for example, the reading or the music applications. So this is the people that we would add also onto the consortium. And so the last question from Alexander, I hope he's still here. It was regarding the emotional classification and how many channels minimum required to do that. Kai, can you give a first estimate?
Well, now the goal that we follow at the moment is to acquire data from ear EEG with 6 channels Probably. So that would be the minimum that we are going for at the moment. What we really need is a possibility to identify a lateralization index. That's what we will do with both ears. And with as much information as possible to get those machine learning algorithms work. And yeah, we will validate how far we get with 6 channels.
So Seth, I'm sorry, I cannot say your first name. Seth Brown. He's raising his hand, so maybe Simon, you wanna give him a boost?
He is
another
sorry, that was actually an accident, but I can follow up on that question.
Yeah.
4 channels is often enough to provide. It really depends on what you're looking for. But that even, 2 channels can provide a lot of information if you're just looking for activity. But 6 channels is very robust. So yeah, I think that's a great start.
Thanks for your input, and we'll get in touch with you. I think you have quite some know-how that is interesting. Very good. So it's 7 o'clock. If someone still has a question, please raise your hands. And otherwise, get in touch with us if you wish to have the material or the contacts of other people. I think we can, like, if you've seen someone specific you want us to make a connection with, also you can get in touch with us. And yeah, for everybody else, also, if you have any inputs for us, drop us an email. And if there are other topics that you would like to hear from us. And it was nice to have this interactive place. Also, like, for us, something that we wanted to do in the webinar, we are meeting so many inspiring people working on EEG, and it's really interesting to us. It was nice to give also a platform for different people to discuss. So yeah, thank you for joining.
Maybe as a last comment before everybody is going into their well-deserved evening or morning or lunchtime, wherever you are, we're doing a weekly neuro coffee session where we are discussing about many things related neuro. And we had so many great inputs about applications and where we could use our technology. So could be cool to do a session where we just do some brainstorming with people who are passionate and creative about that space. So as Severin said, get in touch. Let's build an ecosystem and use each other's brain cells to build cool stuff.